Hello, this is the Crosshair Recovery Wrap developed by Sam Haney, Sydney Sapp, and Andrew Thornton for the 2022 Senior Capstone Project. The Crosshair Recovery Wrap is a readily deployable, disinfectable light therapy device for assisting athletic trainers in treating knee trauma.
Light therapy and how does it help? Exposure to certain wavelengths of light have plenty of therapeutic benefits, but we're focusing on red and infrared light therapy. Exposure to 660 to 850 nanometers in wavelengths has the potential to stimulate cellular activity and accelerate collagen production, which promotes regeneration of connective tissue. Red light exposure has also been proven to accelerate blood flow, decrease muscle tension, and relieve inflammation and pain. We are using red light therapy for athletic recovery, focusing on knee recovery treatment. The main primary target for this device is athletic trainers, and the primary uses include treating collegiate and professional athletes after a workout, during injury recovery treatment, and pre and post game. Through our research, we have found that 41% of all sports injuries are knee related, 1/5 of them involving the ACL.
As found at Thomas Jefferson's athletic training room, some current recovery solutions offered are hot water heating pads as seen on the left, and on the right, the Dynatronics Solaris 709 Plus, which is just a red light therapy device for commercial use.
The goal for our project is to bridge the gap between these two ends of the recovery treatment spectrum. On the one end, the heating pads are unsanitary and they have an awkward and somewhat dangerous learning process due to hot water being used to heat the pads themselves. The long setup and the cleanup takes quite a long time for the fast-paced athletic training environment. However, the wrap itself fits to the desired injured area. On the other end, the commercial red light therapy, users' lack of trust in the technology is due to the confusing user interface. On top of that, there are underdeveloped ergonomic considerations. However, the medical technology using red light therapy itself is quite viable.
To fill this gap, we developed design criteria to determine how we can develop a product to solve this need. This involves two users, the primary user, an athletic trainer, and a secondary user, a recovering athlete. For athletic trainers, the device needs to be rapidly deployed and cleaned in an athletic training environment, withstand low-level disinfection per FDA non-critical disinfection standard, and utilize the skill sets of the trainer to enhance the recovery experience. For recovering athletes, the athletic trainer's advice led us to research that told us that evenly distributed 6.2 to 8 joules per centimeter squared of light on knee ligaments and tendons is optimal for recovery. Then we also needed it to fit comfortably on quadriceps measuring in a 17-inch to 23-inch diameter, and also provide dependable and trusted treatment experience in order for athletes to want to use the product.
We responded to the design criteria by creating a device that has a touchscreen controller and battery, a cleanable silicone exterior, and adjustable magnetic straps for ease of use.
We went through multiple stages of product development totaling 21 prototypes, and the development and prototyping process was determined essential to ensuring that delivering red light therapy was accessible, comfortable, and highly effective for both the athletic trainer and recovering athletes alike. Beginning the ideation process on a red light therapy device started with us believing we could treat any area of the body using a commonly applicable device that's a one-size-fit-all type situation, or as you can see, maybe integrating into furniture. Most of these devices and iterations involved features from common medical devices such as a blood pressure gauge, other red light therapy devices already on the market, and then various health data display devices.
Our initial prototyping began by creating a cloth and foam model with a steel wire structure for attachment. This was originally based off the all-purpose wrap, but then it quickly shifted over to focusing on the shoulder. As we gathered our insights from our first round of prototyping, we realized that the ergonomic considerations of all the joints made it difficult to ensure an even distribution of light. Along with treating the shoulder, we began also testing on treating the knee, and we tested for multiple forms for the best possible fit and coverage for specifically targeted injuries. We also began to continue testing the steel wire for attachment. Throughout this process, we also considered users are going to have less mobility due to their knee injuries.
Moving on to round 2 of development, here we determined that additional fastening to be necessary beyond steel wire. We found out that an even distance of LEDs from the skin is more important than wrap compression, and we also started to ideate on user interaction and the battery module. Design development for round 3, we focused on ergonomic considerations of the wrap with the athletic trainer interaction. This involved going to the athletic training office. The wrap design focused on covering targeted ligaments and tendons surrounding the knee, as this was determined to be the most optimal area to target. And then we continued ideation of the battery controller module, actually developing some sketches of it and how it would integrate into the wrap itself, and we ideated on the LED configuration. In round 3 of rapid prototyping, user testing led us to increase the dimensions of the wrap to target ligaments and tendons surrounding the knee, also including the knee. We added a second attachment strap for more support, and the wrap design was adjusted to help fasten onto quadriceps and shins better.
For the final round of development, we realized that we had to design a substructure layered in between each layer of silicone. We also began material testing with athletic trainers and athletes, testing the silicone itself and the magnetic fasteners. We also began developing the battery controller criteria that has to last 3 to 4 20-minute sessions and accept user input. As you can see here, the development of the substructure started with a grid-like system, but then slowly transformed into patterns that would naturally bend around the knee that the LEDs would lay onto. On the right, it's us testing the third iteration of how it actually flexes once it's wrapped around the knee. For our last round of rapid prototyping, we tested the ease of use for the magnets and the fine-tuning of the wrap dimensions itself. We also wanted to test how the controller is viewed and how it also feels on the user while the wrap is attached. The material itself was also tested for comfort.
In finalizing the battery controller design, we made sure to enclose it with the fewest seams or crevices to maximize sanitation and reduce the amount of dirt that collects on it. It required a system on a chip that's capable of driving touch input and allowing flexible user interaction and capable of supporting a graphical interface. In the end, we found out that a battery capable of 4 20-minute sessions would be approximately a 3,000 milliamp hour battery. This was all integrated into an aluminum case that has no charging port beyond magnetic charging on the bottom. After taking our final form-fit prototype with magnets included to Adam Oslavsky, the athletic trainer here at Thomas Jefferson, he was quoted saying, "The fact that I can just as easily treat an injury and clean this device makes it miles ahead of what we currently have." And he also said, "The magnets create a secure fit without too much time spent putting it on athletes."
The crosshair recovery wrap features a highly cleanable and flexible silicone geared towards the athletic training environment. The LED placement was designed to specifically target injury-prone areas around the knee. Heat from the LEDs increases blood flow and also relieves pain, as well as the red light therapy treatment. The LED layout was also designed with a wrap to maintain light leakage through its use. The embedded earth metal magnets initiate a swift attachment and detachment and provide a maximum adjustability for users with quadriceps ranging in between 17 and 23 inches.
As of the construction of our knee wrap, it's 2 layers of silicone sandwiching components with a magnetically attached battery controller up at the top. The battery controller is made out of aluminum with metal pins on the bottom to connect to an embedded ABS base plate inside the silicone wrap. The 2 layers of high temperature grade overmolded silicone rubber contain a polypropylene substructure which is embedded with rare earth metal magnets, and on top of that substructure, our custom LED array is heat staked on top. Our final battery controller module is made up of an aluminum exterior shell, a 3000 milliamp hour battery, the PCB, an LCD housing, an LCD diffusion layer, charging pins, and the magnetic ring for magnetic charging. Here are some orthographic drawings of a front and side profile view of our device, followed by a close-up view of how that battery controller module integrates into the silicone wrap. Any further questions on orthographics or dimensions or manufacturing can be answered in the trade show afterwards.
Our network includes Adam Ozlowski, who is the athletic trainer with Jefferson University Athletics, Becky Flax, who is with Jefferson Textile Design, and Kendra Adams and Andrew Berger, who are both occupational therapists and IED grad students here at Jefferson.
Thank you for your time and watching our presentation, and we'd just like to remind you that we can answer any further questions or comments afterwards at the trade show on Gather.